So let us look at the semantics and details of the code for building a semaphore. Semaphore wait will basically decrement the value of the semaphore s by 1 and wait if the value of the semaphore is 0 or negative, basically if the resource is not available. If semaphore post is called, then it would increment the value of the semaphore s by 1. If there are one or more threads waiting, wake one up. Okay? And basically, this is a very elegant way to basically have some notion of how many resources you can have. Because, for example, if you have 4 cores on your platform, then you can actually run 4 threads in parallel, right? And each core is a resource. So if you have a lock on your processors, you can use a semaphore where basically the semaphore value is 4, because that's basically the number of cores that you have. And as threads get queued and as threads get scheduled, 4 will become 3, 3 will become 2, 2 will become 1, and 1 will become 0, and then you're basically out of cores to allocate to threads. Then if you have multiple threads waiting, the operating system can even know how many threads are there, what is the expected number of threads per core. So basically, if you have 20 threads waiting, you have 4 cores, then you would expect that each core will basically work with 5 threads, will have 5 threads scheduled on it. So if you have these sorts of this sort of information, you can actually do much better scheduling if you want. Okay. So let me ask you a question. How would you implement a lock using a semaphore? In particular, consider the following code fragment. What should X be? I mean, now we are trying to re-implement what we had as locks into a semaphore. Okay, so let's give an example. It's basically 1. I hope that you all got it right. This is how you would basically use a semaphore for building locking mechanism for using a single thread. You first initialize the semaphore to x, okay, and we agreed that x is 1, hopefully. And then you call semaphore wait, okay. So the initialization will not be in the thread; it's probably in the parent or somewhere, right? I mean, the initialization for a shared resource should not be done in the thread unless because otherwise how will the other threads know that resource exists? So you call semaphore waiting on the waiting on the semaphore, and once you return from the semaphore wait, that means that the resource is available. Okay, the semaphore, if you initialized it to 1, then you had that resource available, so you can go right into the critical section. Once you're done, you call semaphore post. Okay, so let's look at this. So you initialize it to 1, and these 2 lines of code. You then call semaphore wait, which basically checks the semaphore. Semaphore is equal to 1, so it decrements the number to 0. Okay, and semaphore wait returns because the number, okay, after decrementing was positive. As long as the number after decrementing, so suppose that you had 4 cores, okay, and you had only 1 core left available. Okay, once a thread acquires that core, gets scheduled on that core, okay, it can when it decreases the semaphore number by 1, you go now from 1 to 0. Okay, so 0 is not negative, which means that there are no other threads waiting, so the semaphore can proceed. And this is an implementation detail, basically. This is how a semaphore, this is how basically wait is implemented. You basically wait if the number is below 0. Okay, after you decrement, if the number becomes anything below 0. Okay, so you call semaphore wait returns, you run in the critical section, you call semaphore post. Once you are done, you increase the number of the semaphore by 1, okay, and you return. So how about if you have two threads now, and you start from 1, you have initialized the semaphore, and this is thread 0, this is thread 1, okay, and they are basically, I mean, let's just assume that they are initializing the semaphore, both of them, in the beginning. So one of them is running, the other is ready. It calls semaphore wait. So it calls semaphore wait. Actually, this code is misleading. Now coming to rethinking about what I just said, the semaphore initialization has to be before the threads. So running call semaphore wait returns, okay, because you had resources, you go into the critical section, okay, interrupt, you switch to the second thread while you were in the critical section. Basically, you call semaphore wait again, you decrement the semaphore is less than 0, so you need to go to sleep, and you again switch to T0. Now T0 runs, and first thread basically runs and finishes its critical section, calls semaphore post, increments the semaphore to 1, okay, and wakes T1. T1 now can start basically after semaphore post returns, okay, can start running. You have an interrupt and you switch to T1, semaphore 1 starts running, you call semaphore wait. Now it returns from semaphore wait actually, because this call will, the wake up call will actually return from semaphore wait, so there will be no other decrementing. Goes into critical sections, in the critical section calls semaphore post, and then semaphore post return, increasing the number of the semaphore to 1, incrementing the number basically. So this example showed two thread. What if we wanted to have n thread? What value should we initialize the semaphore with? Should we initialize it to -1, 0, 1, or n?